Hi everyone, in this video we are going to discuss about one more problem. The problem name is binary tree zigzag level order traversal and the problem number is 103. So this problem is a little modification of level order traversal. If you don't know what level order traversal, don't worry, we are going to discuss everything in this video. So what we are going to do, first of all we are going to clearly understand this problem, what this problem says. After that we are going to move to the logic part. We are going to see how we can solve this particular problem, what should be the logic. And after that we are going to move to the implementation part where we are going to implement our logic in C++, Java and Python programming language. And guys, if you want to see the implementation in your programming language only, then you can move to that particular part. I have mentioned the timeline as well below, right? All right, now let's see what this problem says. Given the root of a binary tree, return the zigzag level order traversal of its node value. That is from left to right, then right to left for next level, and alternate between. So guys, it says that we have to do just level order traversal, but in a zigzag manner. So what is that zigzag manner? So let's understand this with example one. All right. So it says that the first direction should be left to right. Fine. So here we have only one node, doesn't matter. So we will get 3 only. On the next level, it says that the it direction should be right to left. Fine. So here we are going to move right to left. That means that 20 will come first, then 9. All right. And in the next level, again left to right. So here 15 will come first, then 7, right? So guys, we can see that it says that the direction should be changed alternatively, right? So here left to right. Again, it should be opposite of that. That is right to left. Then again left to right, opposite of that. All right. So this is nothing but we come to know about the direction. Now, guys, it says that we have to do this level order terms, right? So if we are moving right to left, then right node should come first. Then the next left, we can say right node, then next right node, right? So this is nothing but we are going to do a level order traversal. Fine. So this is clear, right? So now, guys, if you don't know what level order traversal, don't worry, we are going to discuss right now. So let's move to the logic part and see how we can solve this particular problem. And let's discuss about the level order traversal first. So let me write level order traversal. So how we can get this value 3, 29, 15 and 7? Let's discuss it, right? So here I'm going to maintain a one new tree. So I'm going to create a new tree. So that is nothing but root 1. Left and right is going to be 2, 3. And left of 2, let's say 4 and 5. Left of 3, and let's say 6, and right 7. So this is nothing but a tree right now we have. Now we have to do a level order traversal, right? Forget about zigzag. Just focus here, nothing but level order traversal. So how we can do a level order traversal? So guys, remember for level order traversal, we need nothing but a queue. So we just need a queue, and queue is nothing but FIFO if you know about queue, or we can say Lilo. First in, first out, or last in, last out. Whatever come at first, it will remove first, right? It should be removed first, and whatever come at last, it should go out last. All right. So inside of queue, initially we will have a level one. So I will say nothing but level one. This is level one, fine, and we have nothing but one. Initially we will have a queue that is nothing but root, fine. So we have one, fine. Now we are going to say maintain a level 2 and remove all the elements of level 1, and this is queue, so we have to remove in a, we can say, FIFO order, means whatever come at the first, that should remove first, right? Okay, and this is nothing but we can say output, which is for level 1, and this is for level 2, and this is for level 3, right? So we know that here is level 3, so I maintain just 3 output, right? Fine. For level 1, we are going to remove nothing but 1, right? So we are going to remove nothing but 1, so I will write here 1. We remove 1 only, right? And now the child of 1 is going to push in level 2, so that is nothing but 2 comma 3. So we push 2 comma 3 in level 2, fine. Now guys, let's move to the level 3 because we have completed level 1. So now let's move to the level 3. I've maintained level 3, and let's now we are at level 2, fine. So we have completed level 1, we have removed all the nodes of level 1. Now come to level 2, and I maintain a new level 3, fine. So I maintain a new level. Now remove all the elements of level 2. We remove, first of all, we are going to remove 2 because it come at first. So I remove 2. Okay, so I will write here 2. I remove 2, fine. And the child of 2 is nothing but 4 and 5. So I will push in the level 3. See guys, I have to put in that manner that left child should come before the right child. So here you can see that left child of 2 is nothing but 4. It should come before the 5, right? Because it is a right child. So left will come first, right will come later, right? I push 4 and 5, fine. Now remove 3 as well. So let me write here 3. I remove 3. And 3 child is nothing but 6, 7. Fine. Now let's come to the level 3 because we have completed level 2. We have removed all the elements. So for level 3, I'm going to maintain a new level 4. Fine. And here, guys, I'm going to insert all the, let's see, wait for that. Whatever, first of all, what I have to do, I have to remove all the element of level 3. So let's move it. So I will remove 4. So I will write here 4. And I will insert in a queue whatever the child of 4, right? So 4 has no child, so we are going to insert nothing. Let's move to the next nodes, that is 5. I'm going to remove 5. Okay, let me write a 5, and I'm going to insert the child of 5. There is no child. Move to the next one, 6. Same goes for 7, right? So we don't have any child of any this all these nodes, so we are going to go, we are not going to insert any node inside of level 4, right? And here, guys, you can see that level 4 will become empty. So whenever you go to level 4 or any level empty, you can break there, nothing, right? So this is nothing what we are going to do. And you can, if you focus little bit, So we got output that is 1, 2, 4, 5, 6, and 7, right? So this is nothing but we can say level order traversal. So on first level you have only node 1. You can see we got 1. On the next level I got nothing but 2, 3. That these are the nodes which are present in level 2. And on the third level we have 4, 6, 7, 4, 5, 6, 7, right? So how I got this? I got just by using a level order traversal. That is nothing but by using a queue. Now, I believe, guys, you understood this what is level order traversal. That means we are gonna get all the nodes on every. We can say that we're gonna get the nodes which are present on every level, right? So first level we got 1, second level we got 2, 3, and third level we got 5, 5, 6, 7. So how it is going to help in this problem? So guys, we need just I'm going to change the statement little bit. We are going to say this is nothing but zigzag level order traversal, right? So zigzag level order traversal. So guys, for this problem, what we need to do? So by default, this level order traversal just move from left to right, right? So you can see 1, 2. So this was the level order traversal. It printed 1. Then after that, it printed 2, 3, right? It printed 4, 5, 6, 7, right? So it is by default going from left to right. But we need in zigzag right to left as well. So I can say that I'm going to maintain one variable that is nothing but, let's say, status. So let me change the color. So I'm going to say I have a variable that is nothing but status. And by default, it's going to be true, right? So I'm going to say the first level is nothing but status, that is true. Fine. On the next level, the status is going to be the opposite of the previous level. That is, here previous was true, so it's going to be false. Here the status is going to be previous opposite of previous level. So previous was false, so it's going to be true. I hope it makes sense. Now I will just say that just do the level order traversal only. So we are going to get the same output, right? We are going to do a level order traversal. So here on the first level, this was level 1. So level 1, the status was true. So no need to do anything. Just put the same thing 1 in your result. Fine. On the next level, you can say level 2, we have nothing but state of false. So if you are getting a state of false, just do the reverse of that. So 2, 3 is nothing but 3, 2 now. Okay, in the next level, we have true. Okay, so don't need to do anything, just write 4, 5, 6, 7. So I hope now, guys, you understood that what is zigzag level or traversal. What we have to do? We have to just maintain a one variable status that is by default true, and the next level is going to be opposite of the previous level, right? And whenever we are getting a status true, we need to just do anything. We just don't need to do anything. We just need to insert the same thing inside our result. But if we are getting a status false, we need to reverse that particular array, or we can say that particular level, and we have to insert then into our result. So now, if you understood this, then well and very good. But if you did not understood, let's move to the code part, implementation part, and let's see where how we can do this particular thing. I know, guys, this until and unless you don't be practical with this particular problem, you won't get an idea, right? So let's move to the implementation part and see how we can implement in C++, Java, and Python programming language. All right. So here I am with the Python first of all. So what I have to mention first of all, I am saying that we are going to do a level order traversal only. So I'm going to maintain a queue, and before that, let's maintain a result variable which we are going to return. After that, I maintain a queue. All right. So this is a queue which is going to be a collection nodes dq, and here in dq by default I'm going to pass a root. But here in the constraint, if you see that there may be a no root, right? So it may be the case that there is no root exit. The root is also itself null. So I can say that if not a root, then return a result. If root exit, then only insert in a queue. All right. And one more thing that is I'm going to mention here, status. By default, it's going to be true. Fine. Now I'm going to say that while queue has at least one element, you have to keep at it, right? So this queue is nothing but a level for us. I have this much clear to you. So this queue is nothing but level. So first level we have nothing but root, right? So I'm going to say find out the size of that particular level. So I can say length of queue, right? So this is going to tell us the size of that particular queue, or that particular level. And what I'm going to do, I'm going to create a new variable that is temp. So this is going to store the nodes of that particular level only, right? So I'm going to say for I in range of n, I'm going to say pop all the nodes from, or we can say remove all the nodes from that particular level. So I'm going to say data is going, or we can say node is going to be q dot pop left, right? So it's going to pop all the elements of that particular level. So first of all, we have to check whenever we are popping. First of all, what we are going to do, we are going to insert in our temp variable, right? So temp dot append. Let me write append node dot val. Once we appended, we are going to check if node dot left exit. Then what you can do, you can see that q dot append this node dot left. Same goes for right as well, right? Node dot right exit, you can append right as well. I hope this much is clear to you. Now once we are done with this, we are going to come out from this loop. We have remove all the elements, right? Now we have removed all the elements from the level. What we are going to say, we are going to check if status is true, then you don't need to do anything, right? But if status is false, if not a status, that means if status is false, then you have to you can say this temp variable you have to do a reverse, right? So we are going to reverse this temp variable. So we can say the temp is going to be now temp reverse, right? Once we reverse this, we are going to append in our result. So result dot append this temp. and if it status will be true, then it will not go in that particular condition, and it will gonna append the same temp variable, right? Fine. Once we are done with this, we can say we are going to return our result. So this is what we are going to do. Let's try to run this code and see whether it's working fine or not, or we are getting any error. So, all right, so I got an error. What it says that 9 and 20. All right, so it says that I have done something wrong here. So let me find out what I have done. So it's printing me 20 and 9. I have to find the 9 and 20, right? So it hasn't appended because I haven't changed the status, right? So status should be changed every time. So status should be equal to the reverse of the last status, right? So now let's try to run this code. We are not updating the status, so by default we're taking true only, right? So now you can see that all the test cases are passed. Let's try to submit this code. And you guys can see that it's successfully accepted, right? So you can see that it's successfully accepted. Now let's move to the next language, that is nothing but, let's take a Java. And here guys, in Java, what we are going to do, first of all, we are going to check it. First of all, we are going to make a variable, we can say whatever we have to return, right? So we can say list integer is going to be, let's say result, which is going to be new array list. I hope this makes sense if you know Java, right? So if root is null, then we are going to return simply result. But if it's not the case, then we are going to find out, we are going to create a queue, which is going to store tree node, fine, and this queue is going to be nothing but, let's say, queue new linked list, fine. All right, now we have maintained a queue. Now what we are going to do, we are going to insert this root inside of a queue. So we're going to say insert queue inside of that. So let me decrease the size. I don't know which shortcuts applied. All right, q dot at root, fine. Now we are going to say maintain one more variable, that is boolean status, right? Initially it's going to be true, fine. Now we are going to say while q is empty is equal to false, means until and unless q is not empty, you have to keep iterating this particular loop, right? Fine. So we can, instead of is equal to false, we can write here this particular, let me write here this node symbol, right? So this is meaning same, right? So this means the same. Now what we are going to do, we are going to find a size. So we can say int size is equal to q dot size, or we can say int n is equal to q dot size. Now once we find the size, we are going to maintain one more thing, that is nothing but list. So let me write list. This is going to be temp, and we are going to say this is going to be new array list. I hope this makes sense. Now guys, we are going to traverse. Oh, we are going to traverse. That means we are going to remove all the nodes from a queue. So for int I 0, I less than n, I plus plus. Let's remove all the nodes. So we are going to say tree node is going to be q dot poll, right? It's going to remove the node as well as return the node. Now once we got that particular node, what we are going to do this, we are first of all we are going to append in temp. So temp dot add node dot where. Now we are going to check if node dot left is not equal to null. Then what we have to do, we have to append in our queue, right? We have to insert in our queue. So queue dot add node dot left, and same we have going to do with a right as well, right? So we are going to say node dot right if node dot right is not equal to null. I hope this makes sense. Now once we are done with this, we are going to say after this loop, that means we have removed all the nodes, so we must get all the values as well. So we're going to check if status is true. If status is true, don't need to do anything, right? But if it is not a true, that means if it is status is false, then what you can do, you can say that collection dot reverse, just reverse that particular temp. I hope this make sense, right? Once you reverse that particular temp, then it will gonna take the temp as a reverse order, right? So it's gonna make a temp as a reverse array. Now once we are done with this, we're gonna say result dot add this particular temp. But if status is true, then it's not gonna do anything. It will not gonna execute this line. It will simply add that temp variable. All right. After that, we have to change the status. I remember right now. So status is going to be a note of status. Now once we are done with this, we are going to return our result. Let's try to run this code and see whether we are getting error in this language or not. And you can see that all the test cases are passed. So let's try to submit this code. So you can see that it also submitted successfully, right? Now let's move to the next programming language, that is nothing but Java, C++, right? So in C++ also we are first of all going to create a vector of vector. That is, we have whatever we have to return, fine. And here we are going to say result. It is going to be a right. So once we created a result, and then what we are going to say, if we are going to say if root is equal to null ptr, that means there is no value exist in root, then we are going to return result, right? Simply result, return this particular thing. But if there a root exists, then what you are going to do, you are going to create a queue first of all. So I created a queue with the data type tree node, and here what I'm going to do, I'm going to say this is nothing but let's say queue, fine. So this is a queue. Once we are done with these things, so we are going to say we can say q dot push, or we can say push this root inside of q. Now we have inserted this push inside of we have inserted this push inside of q. Now what we are going to do, we are going to maintain one more variable that is nothing but boolean. So that is nothing but status. This is going to be nothing but true by default. Now once we done all these things, we are going to start our loop. So we can say while q empty is equal to false. So we can write here nothing but this thing. So if it is a false, that means there is there at least one element exists in our queue. So we have to maintain that particular level. So we are going to say find out the size first of all. So q dot size we are going to get. Once we got a size, we are going to say just maintain one more vector that is nothing but temp, right? Now we are going to traverse for int I is equal to 0, I less than n, I plus plus. We are going to traverse every node inside of that particular level, and we're going to remove that, right? So first of all, we are going to say tree node is going to be nothing but we can say that q is front, right? Q dot front, and after that we have to remove that particular node as well. Once we are done with this, we are going to say temp dot push where node dot where. So we're going to do node dot where, and after that we're going to check if node dot left exists. If node dot left exists, that means you have to append this particular left node also inside of q. So you can say q dot push that particular node dot left, right? If it is node exit, don't need to do anything, right? And same we are going to do for right as well. So if node dot right exit, then also you have to append this node dot right node inside of q. Once you are done with this, then you will come at the end. So let me make a size first of all little bigger. Alright, so we will come out from loop. We have removed all the element and we have inserted all the data inside of temp. So we're going to say if status is true, but if status is true, then don't need to do anything. You have to append same thing in the result as well. But if status is false, then what you have to do, you have to reverse that particular temp. So we can say reverse, and here we are going to pass temp dot begin and temp dot end. So we are going to reverse this thing. Fine. So once we have reversed this that thing, we are gonna say result dot push back this temp. I hope this makes sense. Now we have done all these things. We are going to return our result. Now let's try to run this code. All right, and here let's see what whether we are getting any error or not. So yes, we got an error. So again, same problem. I haven't updated my status, so I have to say status should be note of status. I don't know why I'm doing the same mistake again and again. All right, now I believe it should get submitted, right? Yeah, all the test cases are passed. Let's try to submit this code and see. Okay, let's see. Yes, you can see that it's code submitted successfully, right? So now we have done our solution in C++, Java and Python programming language, and you can see beat status is 100%. All right. So now guys, if you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.